Yeah, because of two devices. From the other device, I have asked it to record. Okay, so the problem is, so I will advise, so please, those who are attending the class, you must tell your friends that there will be a quiz 3, but nothing else will be considered. Okay, there won't be any separate quiz to be given, because the quiz is, it will be objective quiz, and I have made a big pool of questions. Okay, big pool of questions, maybe 50 questions. It really takes time. Okay, it really takes time to make such a big pool of questions, and maybe you have to attempt 15 questions. I will see, and then or 20 questions, and then it will be reduced to 10, like that it is, because it's a 10 marks weightage. Okay, so you must understand that though you find it very simple, you should not take anything lightly. You should be taking everything seriously. I know the questions I have asked, you may quickly answer, and you may all get 10 on 10 also. That is also fine. Okay, but you must attend the quiz. All right, students. Okay, so let's get started. So we were discussing about basic data structures, right? We started with this data structures. So we will be starting we will be talking about the data structures which we have already seen in our previous classes. Okay, so we started with this, the basic data structure, or the basic, we don't actually call it as a data structure, but we say it as a set. And then we also discussed about dynamic sets. Okay, so we were discussing about this, and then we said we were discussing that we call a dynamic set that supports these operations. There were three operations: that inserting elements into a set, deleting elements from a set, and testing membership. Okay, so we call a dynamic set that supports these operations as a dictionary. Okay, and then we also said that there may be algorithms which may require more complicated operations. For example, in the same book, okay, Introduction to Algorithms, there is a concept of mini priority queue. Not mini priority queue, min priority queue. Similarly, there is a max priority queue. What is special about that data structure, min priority queue? That is discussed in chapter 6. Okay, so that they introduce in the context of heap data structure, wherein you can insert element into any order, but whenever you extract the smallest element from the set. Okay, so the best way to implement a dynamic set depends on the operation that must be supported. So now it all depends on which data structure I am going to use, based on which all operations that data structure is going to provide me efficiently, right? So then we talk about elements of a dynamic set. Okay, so so I am reading it, I am kind of reading it through, because it's the core concept. Okay, so in a typical implementation of a dynamic set, each element is represented by an object whose attributes can be examined and manipulated if we have a pointer to the object. We assume that we have a pointer to the object. Okay, so some kind of dynamic set assume that one of the object's attribute is an identifying key. We assume that we have a pointer, we have an object that has a key. Okay, and we also assume, but it is not necessary that every time it may happen, that the keys are all different. Okay, so if we assume if the keys are all different, we can think of a dynamic set as being a set of key values. Why are we putting this restriction that if the keys are all different? Because that is a basic definition of a set. Whenever we consider a set, we do not contain the duplicate items in the set. You would have seen that, it very interestingly in your compiler design course, right? When we ask you to, initially you used to do some experiments wherein you used to find, or in your FLA labs, when you calculate, find all the substring of a given string, right? So some students do it in C++, or some students do it in Java. Then once you have found out all the elements, all the substring of a given string, then you try to remove the duplicate elements. But few students, they use Python, they use a set operation. So by default, set operation, even when you do set operation, it removes all the duplicates are not added into that, right? So in the finding the prefix, finding the suffix, we ask you to remove the duplicates, right? So that is a basic definition of a set. Okay, so some kind of, so if all the keys are different, then we can think of a dynamic set as being a set of key values. Okay, but it is not a necessary condition. Okay, it is not a necessary condition. When you really deal with the data structure, there might be numbers, which are, there may be duplicates in the numbers when you are actually making an array. That's why you are not using a set data structure. Okay, but any other data structure allows you to have the keys in duplicates. Okay, but if whenever we talk about set, we have to remove that duplicacy in the key values. Okay, so then the object may contain satellite data which are carried around in other object attribute but are otherwise unused by the set implementation. Okay, that is another concept, that an object can contain satellite data. The data is there, but it's a satellite data. What is the meaning of that? So this data which are carried around in other object attributes. Okay, so this is the data that belongs to some other, the attribute of some other object. Okay, but they are otherwise unused by the set implementation. Within our set implementation, we do not consider them. Okay, it is the data that belongs to some other object. Okay, it may also have attributes that are manipulated by the set operations. These attributes may contain data or pointers to other objects in the set. Okay, so some dynamic sets presuppose that the keys are drawn from a totally ordered set, such as the real numbers or the set of all words under the usual alphabetic ordering. Okay, a total ordering allows us to define the minimum element of a set, for example, or to speak of the next element larger than a given element is in a set. Okay, so what we are talking about, ordered set. Okay, so generally, we use the concept of set when we say that the elements of the sets are coming from a totally ordered set. Maybe the set of real numbers or some kind of alphabetic ordering is there. So when we say a set does not forces us to assume the elements are in ordered. They are in order. But when we talk about an ordered set, we assume that all the elements are in increasing order. Okay, so if we are talking, again, there can be a set which is in decreasing order. If we are talking about an increasing order, then we can talk about finding the minimum element, finding the maximum element, or we can talk about the next element from this element. Okay, so minimum element, and if the set is in increasing order, that will be the very first element of the set. Okay, so it depends on where we are using a set, right? And what is, what all operations a dynamic set is going to consider. Okay, so operations on a dynamic set can be grouped into two categories. Okay, the first one we call as queries, which simply return information about the set. Whenever you use the term query, so you query something and you get an information, you get a reply for your query about the set. And the other operation is called as the modifying operation, which is going to change the set. Okay, so here is a list of typical operations. We are going to discuss about some operations. Any specific application will usually require only a few of these to be implemented. Okay, what we have done basically is we have talked about a dynamic set. First of all, the concept of set is not dynamic, right? Because when we assume the set, we assume that it is a fixed set. It is having a property. But in case of computer science, we assume a set that is dynamic, that can grow, that can shrink, right? And it can also have operations about searching an element. Then we are saying that there are multiple operations which we are able to do on a dynamic set. Okay, it is like that. So various operations can be done on a set, but there are various data structures. Now you know that what is the meaning of data structure, how you represent the data, right? So different data structures will be using different operations. Okay, so the dynamic sets gives you a list of operations that all these operations can be done, wherein they assume a key. Every element of a set is an object. You can assume that that has a key and that has a value. And then there are operations given on the dynamic set. And then comes the data structure. That is why we are studying dynamic sets before data structures. Then we will say that not all data structures are going to use all the operations those are available in dynamic set. So based on a particular data structure, okay, what is the purpose of that data structure? That data structure is going to use some of these operations. So we are going to discuss a list of operations from the next slide onwards. And then when we discuss data structure, we will see this particular data structure uses which all operations. Okay, so it's a generic term. Now, when we talk about dynamic sets, it's a generic term, generic operations. So the first operation that we consider is known as search SK. Okay, so what is the meaning of search SK? You know, whenever an operation is given, there are few terminologies that we must understand. Okay, because what is the meaning of that operation will come from that terminology, right? So here search SK means it is a query. It is a query means we are expecting an answer for it. So we discussed two kind of operations. One is one is a query, another one is a modifying operation. So search SK is a query kind of a operation. It is element in S. Okay, such that it is returning a pointer X such that for that pointer X, X dot key is equal to K. Okay, or nil if no such elements belongs to S. Understood? So search SK is a query, and what is the answer of search SK? The answer of search SK is a pointer X. Is a pointer X to an element in S. Okay, so if that pointer, the meaning is there should be a key value pair existing. So if there is a key or only key, okay, if it's a list of key, there should be a key such that that pointer dot key is equal to K. Okay, so X dot key is equal to K, so it is going to return a pointer X if the element K or the key K was found in the set. Otherwise, it is going to return nil if no such element belongs to S. So you must remember what is the meaning of search SK. Later on, when we use search SK, you must know what is what should be the answer of search SK. What is the meaning of search SK in all data structures that we are going to use. Okay, this is a generic term which we will apply for all the data structures. Okay, then we have insert SX. Okay, insert SX means what? S is a set that is given to me, okay, and X is a pointer that is given to me. Now you can just remember that S is a set, K is a key, okay, and X is a pointer, such that this pointer must be pointing to some value, that X dot key I want to insert to the set. Okay, so what it is not a query, it is a modifying operation that arguments the set S with the element pointed to by X. That means X dot key. So we usually assume that any attribute in element X needed by the set implementation have already been initialized. Okay, while doing this insert, we actually assume that X dot key is already having a value. Okay, so what we want is we actually want that X dot key must be inserted in the set S. Now, where it is inserted, to the end, in between, in front, and all will depend on the data structure. We are just generalizing it, insert SX. Okay, it depends on the data structure where the key will be inserted. So that is why we are just being generic, that insert SX means X dot key. X is a pointer to the element. Okay, so we want to argument the set S with the element pointed by X. Okay, then delete SX. Now delete SX means same thing. You know, you have S, you have a dynamic set S, you have X as a pointer. So wherever X is pointing, we want to delete that particular key. A modifying operation, given a pointer X to an element in the set S, removes X from S. Okay, note that this operation takes a pointer to an element X, not a key value. So when you say delete SX, X is actually a pointer. It is not a key value. You are not saying that delete this particular key. You are giving a pointer to that key. So you can just remember S is a set, K is a key, and X is always a pointer. It's very simple that way to remember. Then we say about minimum S. Minimum S is a query. Maximum S is a query. Successor SX is also a query. That means they are the operation. They will just give you an information, but they will not change the set. So it's a query on a totally ordered set S that returns a pointer to the element of S with the smallest key. Okay, so again, minimum S can be applied only because we are talking about sets now. We are not talking about a generic data structure. We are talking about a dynamic set. Okay, so when you talk about dynamic set, minimum S means the set must be a totally ordered set. Ordered set means it will be in increasing order or it will be in decreasing order. Okay, it's a ordered set. So it's a query on a totally ordered set S that what it is going to return, it is not going to return a value, it is going to return a pointer to the element of S that has the smallest key. So you can actually say, to remember, you can just remember X is equal to minimum S, so that you remember that what it returns is it returns a pointer to the minimum key. Similarly, maximum S, a query on a totally ordered set S that returns a pointer to the elements of S with the largest key. Okay, then you have successor SX. Okay, successor SX is a query that, given an element X whose key is from a totally ordered set S, returns a pointer to the next larger element in S, or nil if X is the maximum element. Again, so we will always remember that X is a pointer. Okay, so when you say successor SX, that means you want to find the next value of X. Okay, X is a pointer. X is pointing to a key. X is pointing to a key. So what is the next maximum element? Okay, from that X. And it is going to return nil if X is the maximum element. Here X is a pointer. So when I say X means we are talking about X dot key. So a query that, given an element X, okay, though we are saying element X, it's a pointer X. Given an element X whose key is from a totally ordered set S, okay, returns a pointer to the next larger element in S, or nil if X is the maximum element. X is always a pointer. So it is going to see X dot key. What is the next larger element from X dot key? So pointer to that will be returned. That is your successor SX. Similar operation is predecessor SX. So it is a query that, given an element X whose key is from a totally ordered set S, returns a pointer to the next smaller element in S, or nil if X is the minimum element. Right? If X is the minimum element, it is going to return nil. Okay? Operations on dynamic sets. So those are the operations on dynamic sets. So we already have learned data structures, right? We have discussed lots about data structures. So let's have a quick revision on that. What is a data structure? You know, that way of storing data that facilitates particular operations, right? So you must know by now that not all kind of data structures are good for a specific kind of an operation. For a specific kind of an operation, a particular kind of data structure is good, is efficient. Good means it is efficient to be used. Okay, so data structure is nothing but how do we store the data so that we are able to get a particular operation properly. Okay, so dynamic set operations. So now I told you, right, we have discussed dynamic set operations. Now we will see data structures and we will see this particular operation can be done or not in a particular data structure, and if it is done, what will be the complexity. So dynamic set operations for a set S. Okay, so it's just a quick revision. Okay, whatever we have seen. Search SK tells you, does K exist in S? Right? Does K exist in S? And if that K exists, K is the key, it returns a pointer. Right? You remember that's what we had discussed. That was your search SK. What happened? Okay. I think I pressed something. Yeah. Yeah. So that is your search SK. Then your insert SK is add K to S. Right? Insert S. So we had actually discussed insert SX. You remember we had discussed insert SX. We had said search SK, we had said insert SX, delete SX, right? So whenever you see X, please assume that it's a pointer. But when you see K, you assume that it's a value, it's a key value, okay? So now we can, so in our data structures, to simplify, if rather than X, if we are using K, okay, we are saying search SK means does K exist in S? Insert sk means we want to add k to s. Delete sx. So whenever I'm saying x, we have to say that given a pointer reference x to an element, delete it from s, minimum s and maximum s. Right? So return the smallest element of s and return the largest element of s. Right? So we had discussed that it will return a pointer to the minimum element and pointer to the maximum element. That is fine. That depends on how we are implementing our data structure. Right? So quickly we will do a revision. So what are some of the data structures that we have already seen? You have seen almost all data structures. Okay, we are not going to study a new data structure in this course. Okay, so this is what you have seen. Array. Array is a sequential location in memory in linear order. Okay, and elements are accessed via index. Okay, so quickly you are going to tell me, anyone can tell me, in fact one of you can tell all of them, the next one can take chance for doing the other one. Okay, or if you want to take a chance one by one, that is also fine. Okay, so sequential, so cost of operations, you have to quickly tell me. Search sk. That's why it is coming in animated show, that so that you quickly revise. All of you apply, and you all should agree. If someone is not agreeing, you have to explain. Search sk in an array. What is the complexity? Cost of operations. Okay, so don't feel that I am asking a very simple question, so why should I answer? No, I don't want you to sleep, students. So one of you have to answer. Order of n. Okay, no discussions in this. Fine. Insert sk. Now, do not say that I cannot insert into array. Assume that you have to insert something in the array. Insert sk. Then what is the complexity?
Constant time.
Constant. Any other answer?
N, ma'am.
And so both the answers are correct depending on the situation. Okay, so it is constant if we leave extra space in the array. Right? Otherwise, if you do not leave extra space in the array, it is going to be order of n. If there is no place and you have to insert sx, you have to add space. Okay, or you have to, then it is going to be order of n. You will first create a space, then you will copy the n elements, and then you will insert the next element. So both the answers are correct depending on what is the situation. Then insert index sk. Insert index, see, insert sk and this operation we did not discuss. Insert index sk we did not discuss in my dynamic set operation. Okay, because it is specific to this array. Insert index sk means the index is in a particular index. I want to insert key in a given particular index. So suppose I am saying that insert value 25 at I location. So what is the complexity? Insert index sk. It is order of 1 or order of n?
1 only, no, ma'am.
Why 1? Because array is always considered to be, array will have already index, but in a particular index, if you want to move something, a specific operation, you will have to move the array you will have to move the n elements, to keep a new index, isn't it? Right? Because it's an array. So basic definition we are not changing. We are assuming that array is a sequential access. Right? Now I want to insert an index. Okay, or you can, let's say you are not in, so the meaning is not, inserting it's the meaning is, okay, sorry, the meaning is not that I am updating the value of ai. I am not updating a value ai. I am adding an index in between. Okay, so suppose this is an array. Let's say these are 10 elements. I want to add a new index. I want to add an element in between somewhere. Okay, insert index means I want to add a key with some index. So such that I have added in, suppose I have done at is A5, but then what I want is the previous A5 becomes A6. That is not lost. If you are just so it's a different operation, students. Insert index sk, you can please go through the book also. There the author has properly explained. What is explained is, it is not the update operation. It is not that AI was given to me and I am just updating the value of AI. No, I am adding a new index. The key is given to me in between somewhere. So suppose I want to, already A1 to 10 is there. I want to in between, I want to place A. After A4, I want to add one more index. So whatever was previous A5, that has to be shifted, right? So then it is going to be order of n, right? It is going to be order of n. So insert index sk is, it's not an update operation. I want to insert an index. It is possible, though we don't do it in array. Generally, we don't do it. But if required and we want to do that operation, then it is going to be order of n. Because you have to do so many shifts. No, if you are adding it here, you have to do n shifts there, right? Then delete sx. Sx means a pointer is given and a particular key, that x dot key I want to delete. So delete sx is going to be
theta of n, ma'am.
theta of n. Yes. Yeah, delete. So let's not discuss. I hope all of you have understood. If anyone has a doubt, you can please, we can discuss. It is theta of n. Min of s is going to be
O of n.
okay, O of n, theta of n. Max of s is again going to be order of n, theta of n. All right. So that is about the array. So one new thing we saw, you can please go through the book also, students, for this. Okay, it is this thing only. So you have an array, in between you want to add an index. You want to add, you are not updating an element, you want to add an index. So you have to shift all the elements this side, right? So if you are adding a place, you have to shift. So you are adding one more place here. So this last is shifted here, it is shifted here. So that is one thing new, probably you have seen the meaning of insert index sk. Everything is taken from the book itself. I had shown you chapter number 10. Okay, so what are the usage of arrays? Everybody knows, right? So it is, why do we use array? Basically because it provides us constant time access of particular indices. Okay, constant time access of particular indices. So have we said that? We have said search sk. It has constant time access if you want to access a particular index. That we did not discuss here, no? So if you want to access a particular index, array gives me a constant time. That is one of the use of the data structure, that is called as an array. Okay, so then we talk about another data structure. We will, towards the end, we will talk about stack and queue also. Let's talk about data structure that is known as linked list. Everyone is familiar with this linked list. So you see a linked list here. Again, this example is from the book. I have also written here figure 10.3. Okay, so 10 means chapter 10. This is figure number 3 of chapter number 10. Okay, so what it shows here? It shows here the figure number A shows you a doubly linked list. Okay, that represents a dynamic set 1, 4, 9, 16. You see that? So why this is 1, 4, 9, 16? Because they would have inserted element number 1 first, then 4, then 6, 16, and then 9. Okay, each element in the list is an object with attributes for the key and pointers. Okay, so each element in the doubly linked list has a key. Okay, and then there are two pointers. One is previous pointer and another one is next pointer. Okay, so the next attribute of the tail and the previous attribute of the head are nil. Okay, next attribute of the tail, this is the tail, and previous element attribute of the head are nil. So these pointers, we are calling them as attribute of an element. Okay, so for the last element, the next is nil, and for the first element, I am calling this as first. We should not call first and last. We are calling, so basically we should call this as we can call this as we should call this as tail and this as head. Okay, so that if it's a tail element, Okay, the next is nil, and if it's a head element, the previous is nil. Okay, so we are showing them by diagonal slash. Okay, and then the attribute, there is a specific pointer which we are initializing with linked list, which we call as L dot head. Okay, so the author does not use the term pointer, because when you say pointer, it kind of becomes specific to a programming language. So we are calling it as a attribute, right? So the next, previous, and L dot head, they are pointers. We call them as attribute. So L dot head is a pointer that points to the head element, like this. Okay, so this is one linked list. You all know what is a linked list. What is the figure figure B indicating? Figure B is indicating that the same list, but you have added element number 25 in the list. Okay, you have added element number 25. So how did you add? You added 25 here. Okay, you added 25 here, such that now 25 is pointing to the previous head. Okay, and L dot head is pointing to 25. So the previous pointer was nil, now it is not nil. Those updations we need to do. So for this node number 9, the previous pointer earlier was nil. Now it is not the case. Right? So simple. So then the next figure, see what it is representing. It is representing that from the linked list, from this linked list B, we have removed element B. Okay, so it is not B, the element 4. So what it is showing? It is showing that following the execution of list insert LX, where X dot key is equal to 25, the linked list has a new object with key 25 as the new head. Okay, and then the C is the result of the subsequent call list delete LX, where X points to the object with key 4. Now you had to remove this object. So this is how it has been done. 16 has moved the next pointer of, so it is like this, right? You go to the previous of 4, and next of that becomes the next of this. You have just updated these pointers. Okay, why I said this next and previous thing, because that is going to come next. Okay, so that is your linked list. So linked list, so elements are arranged linearly. Okay, an element is a list. Element in the list points to the next element in the list. When we are talking about linked list, we are generally talked about singly linked list. Okay, we are not talking about, when we say operations, let us say we only talk about singly linked list. Okay, and then we will see how my doubly linked list is little different than that. Where is which operation doubly linked list is more efficient. Okay, so linked list. Okay, so we will quickly do the cost of operations for linked list. Okay, so we will, why the slide is not changing? I'm changing the slide. What happened? Because, yeah, now it is changed. Yeah. So elements are arranged linearly. An element in the list points to the next element in the list, right? So quickly you can tell me the cost of operations. We are assuming linked list, not the doubly linked list. Now we are only talking about linked list. Search SK. I want to search a key K. What is the complexity? Anybody can tell, students. I can see name of, yeah, you can tell, please. Yes?
Ma'am, order of n.
Order of n, yes. Okay, search SK, order of n. What is insert SK? Insert SK.
Order of 1, ma'am.
Order of?
1 constant n.
Order of 1, it is constant. Okay, what is insert index SK? Now insert index SK is the same operation that we discussed in the context of array, that a particular index is given to me. If I am saying that already this is, let's say, head, then next element, I want to place a new element, I want to add a new index. Then here also I have to add a new index, and then I have to move everything next, next, next. Okay, so if an insert index operation is given to me, it is going to be order of n, right? Or it is going to be order of 1 if already my pointer is pointing to the index, right? So insert index sk is, we can call it as order of n, if the index is somewhere in between, but if my pointers are already pointing in the list, let us say there is a particular node, right? So suppose this is the head and this is the tail, so I am always adding an element to the head, and I am already in the head, right? So if I am already in the head and then I am asking to add an index there only, then it is similar to insert sk, then it is going to be a constant. But if in between I am asking to insert an index, then I have to traverse. It's a singly linked list, right? I have to traverse next, next, next. So then it becomes order of n. Insert index sk. Okay, then delete sx is going to be, x means a pointer is given to me. I mean, some key value is given to me, x dot key, and I want to delete it. So it is going to be, delete sx is going to be
Order of n.
order of n. Delete index is going to be order of n, because delete, when I only say delete operation, that means I have to search the element and then I have to delete it, right? So delete sx is going to be order of n. Then when I say minimum of s, it is going to be order of n, and similarly maximum of s is going to be order of n, because I have to traverse and I have to really search all these to find the minimum and the maximum, right? That happens in linked list. So what is the use of a linked list? What is the use, right? The same thing we saw, we could have done this with array also, but what is the smart way that the linked list is providing to me? Okay, so it is also providing me access at a linear time, cost of linear time access. So linear time access of a particular index was the advantage of using array, right? That's what we were doing in accessing the array. It was an advantage, that cost of linear time access. So in linked list also, the linear time access, I am getting, so in my linked list, the advantage of array that was there, right? The advantage of array was the access time was linear, right? But here what we want is we are getting a constant time insertion. We are getting a constant time insertion. That's a separate case. If I am saying that, I am giving a particular index, that is a special case. Otherwise, in linked list, I have a constant time insertion at the cost of linear time access. Okay, so because when you discussed linked list, okay, so we did not discuss, the accessing the linked list, right? That operation I have not given here, right? Accessing the linked list. Okay, so for array also that was missing. Okay. Yeah, so it was, yeah, so okay, in book also it is given only in explanation. So when we discuss about array, access case we have not discussed here. But when we access, it's a constant time access. If an index is given to me, constant time access of particular indices. Okay, but in case of a linked list, what happens? Now, when I want to access, simple, what will be the time of accessing an element, a key? It is going to be order of n, because I should first search the element, right? For searching the element, it is going to take me, every element I have to search. So it is a cost. So that's what the cost of linear time access, constant time insertion at the cost of linear time access. So the accessing is not, the accessing is linear time. The accessing is not constant in linked list. Accessing an element is not constant. You must understand that, right? Because if I want to access this and my head pointer is pointing here, so from next, like that, I have to go, I have to search that element. Okay, so it's a linear access time. It is not a constant access time. But what is constant here in linked list? The insertion is constant, right? Insert at index is a separate thing, but otherwise I know I can only insert at a particular end. So the insertion is a constant time. Okay, that is your linked list. You have already seen double linked list, right? what happens in between, it is slow, you know. Yeah, so this is your double linked list, right? Yeah. So in double linked list, okay, you only should tell me how it is usable, how it is benefit, how it is, you can say, more advantageous than the singly linked list. Anybody can answer. Singly linked list, sorry, double linked list, is it, first of all, is it better than the single linked list? If you say yes, then why and how? Anybody can say. Yes.
Ma'am, it makes traversal a bit easier, ma'am. Like forward and backward, it makes it easier, but space-wise, you will have to maintain 2 pointers. So that's
Okay.
like a
So yeah,
drawback.
okay, it's a drawback. Okay. But you know, there is something that is called as the advantage of double linked list. It says that, you know, when you have to delete an element, okay, it is easier if you know that which element has to be deleted. It is easier to use the double linked list if you know everything about which element you need to delete. Okay. So elements are arranged linearly here also. Okay, an element in the list points to the next element and previous element in the list. Okay, and what does the backlink get us? You know, with the backlink you can, as you said, that you can have the traversal easy. Okay, but it has a constant time deletion, assuming a reference to the item. If you want to delete an element, it's a constant time deletion. Now you tell me, what was the deletion time in single link list? Okay, what was the deletion time when you had a single link list? Okay, so why you said, see, you said delete sx. Oh, it didn't change the slide, right? Okay, so I am here now. Link, it says that the when you are in a linked list, right, and you are deleting an element in a linked list, we said it
Hello.
is order of n. All right, why it is order of n, students? Because we are assuming that we first have to search. It has taken into consideration delete sx, that you first have to find that element. Once you have found that element, that I want to delete this element, then I have to just change. It's a constant time. The same thing applies in your doubly linked list also, right? Same thing applies in doubly linked list also, that once you know where the element is, it will take a constant time deletion. Here also, here when we say delete sx, please remember this, why we have said on in singly linked list, because this delete operation is also assuming that delete sx only, it is telling, right? So delete sx, x is a pointer that is telling that you want to delete x dot key. Okay, you want to delete x dot key means you have to first search x dot key. So that is why on. But if you are already at that index, right, and you know, if you are already here and you already know which index you need to delete, right, then it is going to be the constant time. Will it be or not? Okay, so what does the backlink get us? Okay, so if you have a so it is a reference is given to the item. So in your double link list, you are going to get a theta1 deletion. Okay, but in double link list also, if I do not know which element to be deleted, right? So basically this applied in both. This applies in both single link list and double link list. Both, it applies both, that if I have to search the element, then definitely, and then I have to delete means it is going to take on time. But if the element is already given to me, that is, I already know which element I have to delete. If I know this element I have to delete, right? So I just have to change 2 pointers in double linked list and 1 pointer in single linked list. So that is, we call it as theta 1 complexity. Okay, theta 1 means it's a constant time complexity, but as you said, using double linked list, your traversal becomes easy, because if you are at a particular node, you want to get back, you can get back, but memory wise, it will take more memory, right? So everywhere we will not use double linked list if we are able to work with only single linked list. All right. Okay, so tomorrow we will talk about sentinels. Okay, so deleting from a linked list. Okay, so we will discuss this operation in more detail, deleting from a linked list, wherein we will assume, okay, wherein we will assume that we have already found where the node X is, which we are. So when we consider the deleting from a node from a list, tomorrow we will assume that we have already found the element X. Okay, so in that regard, we will discuss deleting from a linked list, and then we also talk about a new concept that is known as sentinels. Okay, that is there in your book. We will talk about sentinels, and also we will discuss whether in which all cases it is good to use sentinels, or it is not good to use sentinels. Okay, fine, students. So I think you do not have any class after this class, right, today?
No, ma'am.
Yeah. So that is why I did not mind taking your 5 minutes, students, because first 5 minutes were simply wasted just to discuss, whether you guys are there or not. Fine. So let me just quickly check how many of you are there now before I wind it up. Now, how to see that number of 22 attendees, very poor attendance. But anyways, fine. 22 attendees, students. Wednesday we are having the quiz. Okay, the quiz one we are having it on Wednesday. All right. So that's it, students. So tomorrow we'll continue. We will talk about sentinels and what is the use of it, and then we will quickly revise stack, queue. Okay, and that is all. That is what we will discuss, and then we may be able to start with the data structure, with the what is that? With the graphs. Okay, with graphs we'll be able to start with graphs. So these slides I will right away upload. Okay, after tomorrow's class I will upload these slides, because when I ask you one question, that time, so I don't want you to see in the already given slides. All right. So fine, students, we'll end the session now. Okay. Thank you.